So we have a couple of new theorems. One of them says if a line is parallel to a side of a triangle that intersects the two sides, then it divides it proportionally. In other words, if these two lines are parallel, then AD is to BD as AE is to EC, and the proportion is written right here. Another one is the converse of this. It says if those sides are proportional, then the lines are parallel. So we're going to use these in our problems. The first problem we notice is the original theorem. We know that because these lines are parallel, these are proportional. So 6 over 15 equals x plus 5 over 20. Now, the way that I do this is I put a dotted line right here in the center and I don't cross that line. I set up the proportion. I'm going to distribute 15 and I'm going to solve for x. Remember that the question could ask us find x, like in this example, but the question could also ask us to find this length. It just depends on what the question asks you. For this one, I'm going to draw a line again, and I'm not going to cross the sides. So 8 is to 2x plus 2. 9 minus 5 is 4. 4 is to 5. So 8 over 2x plus 2 equals 4 over 5. I go ahead and cross multiply, and then I have to distribute, and I solve for x. In the next example, I'm going to go ahead and make my dotted line. 25 minus 10 gives me 15, so I know 15 over 10 equals 15 over 9. And I look at this proportion and I realize the proportion is not true. Therefore, these lines cannot be parallel. It's important that you remember the first theorem states a fact. The second theorem says that you have to make sure that the segments are parallel for the lines. The segments are proportional, for the lines to be parallel. And then if you look at the next example, again, I draw the blue dotted line. 70 minus 60 gives me 10, so 10 over 60 equals 13 over 78. I reduce both of those fractions, and these two segments, LM and EF, are parallel because they are proportional. So make sure that you look at these theorems to make sure you understand. If the segments are parallel, then the segments are proportional.